Hi everyone, this is Neha and welcome back to my YouTube channel. In today's video, I'm going to be talking about a different kind of smart contract language known as Clarity, which is the smart contract language used on the Stacks blockchain. So previously I've made a couple of videos on Stacks, so if you haven't checked them out before, then definitely go ahead and check it out. I'll try to link them up here. So we're going to be talking a little bit about Clarity as a language, the features of Clarity, how is it designed, and how is it different from the existing smart contract languages such as Solidity. And at the end, I will also be providing you with some resources that you can use to learn Clarity and maybe even get a job in the Stacks ecosystem. So let's get started. So before we deep dive into what Clarity is, let us first speak a little bit about the Ethereum virtual machine and the halting problem. So basically, the Ethereum virtual machine is Turing complete in nature, which implies that given enough time and resources, it can solve any problem no matter how complex. But that being said, any Turing complete machine suffers through something known as the halting problem, which means that given any input, it cannot determine beforehand whether this input is going to stop or if it's going to run forever. There is no way to actually determine this beforehand and stop the execution at that point of time. And that is the reason why Ethereum came up with the concept of gas, in order to not abuse the network in case of certain inputs that can lead to the halting problem. So given a specific amount of gas limit, if in case the input runs into something like this, by running out of gas, it will make sure that the system will halt at some point of time. But through Stacks, Clarity came up with a better solution to this problem by building something known as Turing decidable. Now, Turing decidable systems do not suffer the problem of halting because these systems are decidable in nature. So decidability here basically means that there is certainty what the program will actually do, which means that there would never be a case of halting because the program will definitely complete execution at certain number of steps. And because of this decidable nature, it is possible for us to actually simulate and understand on all types of input what would be the output for any particular function call, and hence compute any sort of execution cost beforehand. There's another major way in which Clarity differs from other smart contract languages such as Solidity, because Clarity is actually interpreted and it is not compiled. So if you talk about smart contract languages like Solidity, they're first compiled to bytecode and then they are committed to the blockchain. And this leads to basically two issues. Number one being that since first the code is being compiled to bytecode, if by any chance there is some sort of error in the compiler, there can be bugs in the bytecode that can actually lead to the smart contract not functioning the way that it was supposed to. And another being that since we all know about the crypto world and how many scams etc. are going on, it becomes very difficult for any person to understand the code that has been submitted to the blockchain, and it is very difficult to verify through bytecode whether what the smart contract promises to do is actually what it's doing. So by being interpreted instead of compiled, Clarity code is committed as it is directly to the blockchain, which reduces this complexity of having first compiled to bytecode, and second, it makes it very readable and understandable for non-technical users to just go through. With Clarity, what you see is what you get. There are a couple of other features that Clarity has that makes it really secured by design. So if you actually look at the different hacks that have happened in the past in the blockchain world, Clarity's design ensures that we are safeguarded against these sort of hacks. For example, Clarity does not allow re-entrancy. Re-entrancy basically meaning when one smart contract calls another, which then calls back on the first contract or tries to re-enter the contract. And a lot of times you'll see this is how hackers try to drain your funds by re-entering that function again and again. But by design, Clarity does not allow these sort of issues. Clarity is also very stringent when it comes to overflows and underflows, so it will just try to abort the transaction instead of it leading to side effects which developers were not prepared for. Another smart condition that has been written by the developers of Clarity is known as post conditions, which can be attached to transaction to assert that the state is being changed in the way that we want it to change, and if that is not the case, the transaction automatically gets reverted. And the last but not the least, since if you've already watched my Stacks video and you know the importance of Bitcoin in stacks and in the proof of transfer consensus mechanism. Clarity can actually be the state of the Bitcoin base chain, which means that any sort of Bitcoin transactions can be actually used as triggers within the Clarity smart contract. How good is that? And that was pretty much all about different features of Clarity. If we talk about the actual syntax of Clarity, you would find it more not on the object-oriented programming side, but on the functional side of programming. It has a more Lisp style of syntax over there, with everything being written around in cute parentheses. And for you folks to actually go on and learn Clarity by building simple smart contracts, we have some amazing resources, mostly by Marvin Jansen. You can find the Clarity book, which I would put down a link for, and a couple of other tutorials on Hero's website. Definitely do check it out and try to build something on Clarity on Stacks. So this was all for the video. If you really like this video, then please like, share, and subscribe to the channel. And as always, I'll be coming up with more content on blockchain. Do give me a follow on Twitter or LinkedIn. That's it. Take care. Bye bye.